Welcome. In this video, we'll be learning about regression analysis. Regression analysis is when a real-world problem can be described in a mathematical equation. It is called mathematical model. For mathematical modeling to exist, data must be gathered comparing two quantities. A scatter plot is generated and a curve fitting is used to determine what kind of relationship the two quantities have: linear, quadratic, cubic, exponential, logarithmic. Linear regression uses a variable called the coefficient of linear correlation, lowercase r, to determine the strength of the linear relationship between the two variables. Because it's linear, r is the slope of the line. R can be anywhere between -1 and +1. If r is equal to 1, then the relationship between the two variables is said to be a perfect positive correlation. If r is equal to -1, then the relationship between the two variables is said to be a perfect negative correlation. The closer the correlation coefficient is to 1, it is said to have a strong positive correlation. The closer the correlation coefficient is to -1, it's said to have a strong negative correlation. The closer r is to 0, the two variables have no correlation. The following scatter plot summarizes the interpretation of correlation coefficients. If r is equal to 1, notice that all the points are on the line. If r is close to 1, the data points are close to the line. And if you notice that r is equal to 0.42, they're around the line but not that close. As you can tell in those two examples, the line itself is positive. That's why the correlation coefficient is a positive number. Looking at the bottom, the same thing with the negative slopes. -1, all the points are on the line. -0.91, they're close to the line. And -0.42, they're around the line. To find the coefficient of correlation on a TI-84 graphing calculator, go into Catalog. Scroll down to you get diagnostic on, then hit enter. Hit enter again and make sure the screen displays done. Steps to graph a scatter plot on a TI-84 graphing calculator. Step 1. By going into the stat and then edit, enter the first set of data values x into list 1 or L1. The second set of data values into L2, making sure the data values match up. The data values are ordered pairs. Step 2, above the y equals button, enter into stat plot. Turn on one of the plots. Make sure the type is the first icon, which is a scatter plot. Enter into xlist, the list that contains the first set of data values, which is your L1. And ylist for the second set of data values. Step 3, on the main menu, hit graph. And under zoom, hit zoom stat, which should be number 9. So for the first problem, let's look at expenditures on pets. Data on the total U.S. expenditures on pets, pet products, and related services are given in the table below. Model the data with a linear function, then using that function, estimate the total U.S. expenditures on pets in 2005 and predict the total expenditures in 2015. Answers may vary depending on the data points used. So if you take a look at the years, comma x, what you want to do is you always want to have a base year. So when they tell you that 1991 is 0, they're saying starting in 1991 is when this table started. 1994 is 3 years later. 97 is 6 years, and so forth. So if I'm looking for 2005, that is 14 years after 1991, so my x is going to be 14. If I'm looking for 2015, that is 24 years after 1991, so that means x is going to be 24. For me to actually graph this and find the equation, first thing to do is type in my data into L1 and L2, making sure they match up just like the table. Then I want to make sure I turn on the stat plot using the type. Xlist, I put my x's in L1. Ylist, I put my y's in L2. Then, in order to graph, I went to zoom number 9. And the last one would be the ordered pairs given from the table. To find the linear regression equation, what we want to do is, under the stat and then under calc, scroll down till you get LINREG, AX plus B button and then hit enter. If the X values are in L1 and the Y values are in L2, then you can just hit enter again. What that does, that produces an equation of Y is equal to AX plus B. So the equation that we're looking for here is Y is equal to 2.62857 X with a y-intercept of 17.41429. The r squared is called the coefficient of determination. It decides which function is the best fit. The closer the number is to 1, the better the fit. R squared is the coefficient of correlation squared. To have the linear regression equation appear on the scatter plot, after you hit ln reg AX plus B, then hit vars, yvars, function, then y1. After you hit enter on that, it still produces the equation of y is equal to ax plus b, but then it also puts it into the y equals equation. So when you hit graph, not only do you have the points, the scatter points, you also have the equation of y is equal to 2.62857 x plus 17.41429. It's not, the points are not directly on that line, but as you can tell with the r value being 0.995, they are pretty much close enough. Still using the same data points that we have, let's go ahead and evaluate what the expenditure would be for 2005. So again, I have y is equal to 2.62857 x plus 17.41429. For 2005, we said that x was 14 years later. So let's plug in 14 in for x. And that value is going to be $54.2 billion. If I want to predict the value that's going to be spent in 2015, I want to let x be 24. And that means that in 2015, we can predict the annual expenditure to be $80.5 billion. There is no difference in the process for a quadratic model, cubic model, exponential, or logarithmic. It is still under stat calc. Quadratic is number 5, cubic is number 6, quartic is number 7, logarithmic is number 9, and exponential is number 0. To clear a list from the graphing calculator, go under List and go Clear List, and then type in above the numbers 1 through 6. You should see L1 through L6. If you want to clear multiple lists, make sure you separate it by a comma.